About the different uses of radioactivity in different applications that we know of in science and medicine. So let's talk about the different categories. First, we can use them in several applications as creating artificial isotopes. For example, we can have a stable isotope like cobalt-59, and then using neutron shooting we can create an unstable isotope like cobalt-60, and that isotope will further break down and release some energy and release some other neutrons, and we can generate some release of nuclear energy using those artificial isotopes. Another medical application that we can have, which is in medical scanning, like the X-ray scan or the CT scans, and also we can check for the thickness of different materials in more of an industrial application using radioactivity, and smoke detection in alarms, and crack detection for the pipe system, and then we can use it for quality control. And we talked about carbon dating in 5.5, which is basically knowing the age of different living organisms using the decay rate of carbon-14. And also we can know the age of different rocks using this decay of isotope material inside rocks. So let's talk about the first medical application, which is medical scanning, which is basically it works by using a tracer material or tracer isotope where they ingest it, and then they can scan using gamma radiation or using the gamma screen, and then it will capture the drop or the liquid that the person will consume, and then it will decay over 24 hours, and that will help us understand the function of the body organisms, like different organs function, and the performance over time by the patient, over a short duration. Usually a very low concentration over a short half-life isotope will be consumed. And then we can also check in more industrial application the crack detection. As we said, we can see it in different piping systems or like defective pipes, using gamma rays, by shooting gamma rays at the spots, and using film, radiography film, to capture the voids on the film. So basically when we shoot the gamma radiation over the void, it will create some imprint on the film, and then we can know from the radiography film that this spot has a certain void or crack, and then we can detect it and work on fixing it. Another thing is adjusting the thickness for aluminium sheets in some industrial applications, where you have the aluminium foil being rolled out using rolling pins, and then the radiation will shoot in some beta radiation, and the radiation will be emitted and pass through the thickness of the aluminium, and the thickness will absorb some of that beta particles, and according to the thickness some percentage of that beta particles will be absorbed, and the thickness can be adjusted using a sensor that gives feedback to the rolling pins, where they can adjust the spacing accordingly or appropriately according to the required thickness. Now the carbon dating, we talked about it before, but we can recap it. So any living organism during its life cycle, it will consume carbon-14, gain carbon-14 from the atmosphere by breathing and consuming other dietary plants or animals, and then they can lose some of that carbon-14 in the process of decay, and when they are in their death stage after they die, they do not gain any carbon-14, and they lose it due to the decay of carbon-14. So if we know the half-life of carbon-14, which is 5,700 years, we can have the percentage of carbon-14 present in the dead animal, and we also know what is the usual starting percentage at 100%, what is the initial amount, and then we can figure out how many half-life cycles have been passed and how many years have been passed since the living organism has died.